Hi, I'm Darren and welcome to Level Up EE Lab. I decided to take a break from working on my DX60 project and tackle something a lot simpler. So, how about an IM-103 line voltage monitor? Let's check it out. This Heathkit IM-103 is one of several items from the George Collins collection that I examined way back in my 1000 subscriber episode. During that examination, I found that it was non-responsive. Internally, there didn't seem to be anything catastrophically wrong with it, so I gave it a rating of 2 on a 5 scale as a restoration candidate. But before I get into further diagnostics and repair, let's talk a little bit about what exactly is an IM-103. Functionally, it's an AC line voltage monitor. You plug it in a power socket and the analog meter displays a reading that is indicative of the RMS value of the AC voltage. That's it, nothing else. On the side, there's a slide switch and 2 potentiometers that are used during calibration, but other than that, there are no user controls, not even a power switch. Its specifications are very simple. A claimed accuracy of 2% after a 2-point calibration seems reasonable, especially considering the simplicity of the circuit and that the meter is not an anti-parallax design. This little guy does consume 4 watts of power though, which isn't that much by itself, but if you do leave it plugged in 24/7, that's on par with a modern 40-watt LED light bulb. So what's the point of this thing? Does it really do anything useful? I mean, why would I care about monitoring my AC power voltage any more than I would say monitoring the water pressure coming into my house? Well, if you're like me, living in a metropolitan area, you probably have pretty stable AC power and you don't really need to keep an eye on it over time. But there are situations, let's say, where you're in off-grid power and you've got varying load, or if you're doing amateur radio field day and setting up temporary power with even more varying load, you might want to keep an eye on your generators and other sources of power. Another nicety is its simplicity of design and construction. After all, it was sold as a kit, and simple kits like the IM-103 were often someone's introduction to the world of electronics. Many times that would lead them to a stronger interest in electronics, and if they enjoyed the experience of putting this little guy together, maybe eventually they'd work their way up to tackle an HW101. Okay, on to troubleshooting. And the first step, even before I clean it, is to make sure the meter is working properly. If it's dead, then this project is too. Fortunately though, it looks like the meter is working just fine. All that I needed to do was connect it in series with the 10K ohm resistor and carefully apply low voltage. I even took the time to record the amps and meter voltage at each of the major gradations. Here's the data. It's definitely still working quite linearly. Also, the data indicate that it's 200 microamps full scale and its effective resistance is around 980 ohms. I also used this data to build a best fit linear equation to relate current draw to meter reading. All this work will come in handy for building an LT SPICE simulation. Yup, I couldn't resist. There's nothing quite like building a simulation to convince yourself that something that's been around for decades actually does work. So here it is. First and foremost, the simulation does confirm that when I apply various AC voltages, I do get relatively steady DC current through the meter. So I expanded my simulation to run at 2 input voltages. 141.4 volts peak and 183.9 volts peak. Those equate to 100 volts RMS and 130 volts RMS respectively. Then I calculate the average current flowing through the meter between half a second and 9/10 of a second, just to capture the smoothest portion of the data. And then finally, I applied the best fit equation from the data that I collected, which then predicts meter pointer readings of 102 volts and 135 volts. That's really close to the actual 100 and 130 volt RMS values. Nice. Also, that's with the low limit and high limit calibration pot set to mid-range, so there's room for adjustment. Just for grins, I checked the current consumption and power dissipation on the components, and I'm glad I did because I found a couple of concerns. R2, this 10K resistor right here, dissipates over 2 watts at 130 volts RMS input. Now Heathkit used a 2-watt resistor there, so that is clearly undersized and needs to be increased. In the unit that I have, it's already been beefed up, so I'm okay. Also, my observation has been confirmed by the online experiences of others who've restored these IM-103s and have also beefed up R2. In addition, R4 can see just over 800 milliwatts, and Heathkit used a 1 watt resistor there. So it's marginal and it should be increased too. All the other components seem to be fine for their ratings, no other issues. Now that I've built a model that matches reality, it's time to get back to the troubleshooting. So if the meter itself is working fine, what else could be wrong in the circuit that's preventing the whole unit from working? So quick troubleshooting, the fuse checked out fine. And what I thought of doing next, rather than trying to probe each component with no power on it, I decided to hook it up to my dim bulb tester because I can set that to virtually any AC voltage that I want, between just a few volts all the way up to full line voltage. And very quickly, with just applying 30 volts, which kept probing through here relatively safe. 30 volts is a lot less hazardous in an open circuit board like this than full line voltage. I was very quickly able to figure out that R4, the very same 18K resistor that I was just talking about in my simulations, well, it checked out open circuit and it fits right in here. I did not have in the parts bin a 1 watt, 1% 18K resistor. I just had a plain old, I think it's a half watt carbon comp. But anyway, I dropped it in place and that fixed the problem, which I'm going to demonstrate right here. But before I do, I want to give a plug for the lowly and kind of humble dim bulb tester. I think if I went back and looked at all my videos on this channel, I probably have used the dim bulb tester more than any other meter or piece of test equipment, maybe even more than a multimeter. It just seems to be so useful. So I would highly recommend, if you're doing your own electronics lab, either buy one or build one custom. If you can get an auto transformer like this that you can adjust, then you can build, and also buried inside here, of course, is an isolation transformer. It's pretty easy to whip one of these up, and it's incredibly useful. So, all right, enough plugging it. Let me turn this onto its front face. Much easier to watch the meter that way. So here we go.
This item contains hazardous voltage and safety precautions must be followed. If you're following along and working on your own version, you're doing so at your own risk.
Get this up above 90 volts so we can see something. And there we go. It's starting to respond. Now it's not matching that meter because I would think the calibration's off, but the fact that it is working, it's going down when it should go down and up when it does go up, that's a good sign. So fixing that one open resistor seemed to fix the problem why it wasn't working at all. So what I need to do next here, of course, is replace that with the proper resistor. I did take the time to inspect all the other resistors and components here, and there were a few other resistors that checked a little bit out of spec, and I've also got to deal with this big electrolytic here. That's got to get replaced. I've ordered the parts and I ended up going with, it's actually a 5 watt 18K 1% resistor that turned out to be the most economical one to buy. So that guy right here will drop in right here, and then of course I got a few other parts like I say, and this is the replacement cap. So this is a 68 microfarad 250 volt radio. This is going to replace that guy, and what I think I'm going to do is take this out and put in another terminal strip down here to make routing all the wires and tying in the cap real easy. But before I start putting components in, I want to strip everything out of here so I can properly clean this case, and then similarly for the cover, they are pretty filthy, and I think getting all the electronics out of there will make cleaning it so much easier. Alright, I finished the cleaning and the repair work on the IM-103, so I'll kind of just cut to the chase here and go through what I did. Ultimately, I did pull all of the internals out of this housing. It made it so much easier to clean, and it was pretty easy just to take this all out in one big piece, and of course take the meter out as well and clean it. And then putting it back together, what I've done here is something I've done on a lot of my repairs. I just take a copy of the schematic, and as I go through it and trace out each portion of the circuit, I just mark it with a highlighter to verify that it's connected right, and if I've had to make any repairs or changes, that I'm following the same schematic. So did that. Everything has turned out fine. It took me probably about 2 to 3 hours to do all the cleaning and the assembly work, And one of the most important changes that I made here was I installed a 3-prong cord. This is, of course, a metal housing, and it's going to be plugged into line voltage, so it's always a great idea to replace the old 2-wire cords with a 3-wire cord, and then have a special connection here right to the frame, right to the casing in this particular unit, so that the ground is connected, and this outer housing is now connected to utility ground through the 3rd prong, of course. So did that. Everything worked out pretty easy. In fact, I barely had to enlarge the hole that was there for the existing grommet to put in this grommet that is a very nice strain relief. I got a collection of these that I got at a Handfest years ago. These are perfect for a 3-wire cord like this. So what I think I'm going to do at this point, I'm going to reset the camera and zoom in a bit closer so I can really point out what I changed here on the circuit. So one of the first things I had to replace here on the circuit was the old electrolytic cap. Remember, it's this big guy here, and it was tucked right in here underneath this resistor. This is the replacement, and I did end up adding a 3-position terminal strip here, and I put it in this location to keep it away from this resistor. This guy gets fairly warm and don't really want to have that filter cap next to it, so there was plenty of space to drop it in down here. Here's R4, that 18K resistor that I had to replace. So this is a 1%er, so this now meets the original Heathkit specs. And then just a little bit of rewiring. The yellow wires here are all new, just to interconnect all the various elements of the circuit. The fuse was already there, so didn't have to add that. And then I rechecked the other precision resistors, and they were all within spec, so I left them alone. So at this point, what I need to do is hook this up to my dim bulb tester and do the calibration. Calibration. It's actually pretty easy on this IM-103. There's 2 controls here, a low set point and a high set point. And then there's the little toggle switch here in normal position and cal position. Now, oddly enough, if you're doing a 2-point calibration, which I'm doing here, you don't put it in cal mode, you leave it in norm mode. So I'm glad I read the manual for that, otherwise I would have been really scratching my head. So once again, I'm going to use the dim bulb tester, and because it's got the auto transformer in it, I can dial into the calibration voltages. So here we go. And of course, I did cheat before this video, meaning I did verify that the unit was actually working. It'd be kind of funny if I tried to calibrate it right now and it didn't work. So let me crank this up. I want to try to get to 95 volts. So that's going to be just off of the low point on the meter. So that's pretty close. So now I adjust the low setting. Screwdriver in there. Bring that up. There we go. There's not a mirror on this meter, so I have to look at it straight on to try to fine tune it. So that looks pretty good. And then 135 is the high point. Now I'm not sure I can get all the way up to 135 with my dim bulb test, but I'll take it up as high as I can get it. So that's 128.8. We'll call that 129. And I'll adjust the high cal point to 129. Okay. And then the procedure says just repeat that back and forth until you get it dialed in. So let me go back to 95. Of course, I'm trusting that my little inexpensive DMM is accurate, which I'd say it's accurate enough for what I'm going to be using this monitor for. And look at that. It didn't need another adjustment. It's still right at about 95. So I'd call this good. I'd say this is ready to be put back into service. So let me dial this down. And then in the final step, of course, I got to put the back cover on it, and then it'll be ready to go. Here it is all done. Put the case and cover back together, and it still has the original Heathkit serial number sticker on the back, along with this little note. I did have to replace the feet. They were on the bottom. They were dried up chunks of rubber, so I just put 4 new felt pads on there. And now it's good to go. Just sit on top of my shelf or sit on top of a generator, wherever you want to monitor line voltage. So let's plug it in and see it in action. And there you have it. So my lab is running around 126 volts right now.
It's actually a little higher than I would like, but who knows what it's going to be like a few hours from now or tomorrow or whenever. Now that I've got a monitor, I can keep an eye on it.
So that's it. Just a single episode for a simple project. Next time I'll be getting back into work on my DX60 project, and I've got some good news to report. I have found solutions for the problems I was having with the meter, with the distorted load coil, the broken coupling, and a few other things. So I'm excited to get back into that project and start making some progress again. As always, I thank you for watching my channel. I do hope you enjoy this material. And until next time, bye for now.